Okay, these are the Sonoff switches as you receive them. I thought I'd put this together just to show a few people how you can modify this. At the moment it comes in, and we come in with a 240 volts on the input, live and neutral, or sorry, neutral and live I should say if we follow the legend. And the output again is a neutral and a live output on 2 cores. So this will switch 240 volts in regard to your Wi-Fi, telling it to connect or disconnect. For what I want to use these units for, this isn't what I want. I want to take a live and neutral feed in from the mains, but the output relay on this side I want to be what we call volt free, i.e. the relay connection has no voltage on it, and we bring our voltage in. So we'll bring a live in from 12 volts or something into one connection, we'll switch it and we'll come out of the other connection. So to do that we need to do a few slight mods on the board. Now these come together, they're not sealed, so quite simply just by putting a blade in or something we can pop him open and we can get to see the circuit board, which we will pop out here, and we can see it looks a quite nice circuit board, relatively well made. These slots here, these are all to give isolation between what are the mains portions, because this would be the mains voltage here. So they cut this slot between the board, and the same on this side to separate the mains voltages. So the mains voltage coming in here is separated from the circuit board, and these slots all give isolation between sections of the circuit board which are at mains 240 volts and the lower voltage required to operate the circuit. Now we are going to need to change a few connections, because basically as we look at this we can see that our mains voltage comes in, it goes through this fuse here, and this fuse feeds onto this circuit board which feeds this side, and then if we turn in over we can see that this mains connection which comes in also goes to the relay. So we are going to make a few changes here. The first thing we will do is we will remove this fuse, take this fuse out of the circuit board, and we will also remove this cable here. This one is taking our neutral from our mains through to our terminal block, so we are going to remove this cable out of here, and we're going to divert this cable across to this side eventually after we've done some mods to the circuit board. The tools which I'll be using will obviously be the soldering iron and my solder sucker remover, which will suck the solder out so it'll let me take these parts out. And I'll be using the trusty Dremel again. I have one tip here which is like a little burr, which is great for getting rid of the copper and the covering and cutting through copper tracks. We'll be using a small drill bit to drill some more holes. There'll be 2 drill bits which we can use, so whichever one's best for us. And this other little bit which I quite like, this is a diamond rotary file, and I find that this is great for when I want to cut slots. So I want to be cutting slots in this to keep this isolation of the mains voltage away from what will become the low voltage. Okay, so we're going to be getting on with this, and the first thing that we're going to be looking at doing will be to remove this fuse and this cable from the relay, and then we'll pop back in a second once we've done that, and we'll see what the board looks and then what we're going to do to the board. Okay, coming back to the board, we've got the desoldering tool here that's nicely warmed up now. So the first thing we're going to look at doing is to actually see if we can remove this wire here once the tool gets warm enough to do the job. We can suck the solder out, which then allows us to remove this wire. I'm going to cheat a little bit, and I'm going to put this clip onto the fuse, we're going to look at doing a similar thing here. On the other side of that point, which will be here as well. And we remove the fuse. So we can put that away for a moment. In fact, while I'm here, what I'll just do is just take some of this solder away that we don't need. And we can put that away for a moment. We are finished with that device. So now looking at the board, we can see we've got a bit more clearance. That is our fuse, which we will be putting back, and this is the wire which used to carry the neutral, which we're now going to connect, and we want to connect this wire to this other point on the relay. So what I normally do is I will normally make this hole here slightly larger, and we will drill a couple of new holes. These were the two holes used by the fuse. We're now going to move this fuse, and we're going to pick a hole up from here, and we're going to bring the fuse across to here. So we want a new hole here, a new hole here, and then what we'll actually do is we'll cut through that circuit board in a line across there, and we'll open it up so we have an air slot all the way round. We can't just cut this track on this side, because as that's a 10 amp supply, what they also did is they put a track on the top of the board as well. So we're going to cut a slot completely through there, so we have isolation between the two tracks. But first of all, we will look at drilling some holes in here and see if we can get this to do what we want. Okay, we'll drill the hole through. We want to just basically go through here, so I'm going to try and pick up onto one of these points, and we'll just ease this small drill through. Our small point through which will do our connection, and now our next point we want. It's going to come across, and this is the more difficult bit, just getting onto this small part here. So we want our fuse to sit across and enough room for our base. Now we'll see if we can get into here, shall we? And there we see we've got our two new holes to mount our fuse, and then our next job will be to basically cut our track away through here, open this hole back and increase this gap here to give us our air gap, which we shall do in a moment. Okay, we've managed to put our two holes in, which we was hoping to do. So you can see we now have a new hole here and a new hole at this point. So this will be our new position for our fuse. What we're also looking at doing is opening this hole up a little bit larger for this cable to solder into. So we just need to take that a little bit larger, and that's what I quite like this little rotary file for. It's a little bit easier to use. Okay, I also need to remove some of this lacquer, so we can just ease that very gently, because we're going to want to solder onto here in a moment when we put our fuse back. So just being very gentle, just to take the lacquer off, and do that. I did have a little brush here somewhere a moment ago. Oh, there it is. Let's just Anyway, I found a little brush that we was going to use, so I'll just give that a little brush off. You can see we've now opened this hole up large enough that it will take this connection when it solders in. Now our next task to do will be to cut a track through here and separate those two sides from each other, and we'll continue this hole through, or this slot through the track, and that will give us isolation between our mains voltage, which this side we're going to be at 240 volts, and this side will be at our low voltage 12 volts, what our relay will be switching. So the next task we'll do is we will ease a track through here, and basically we should be able to do this using the Dremel, and I'll use the rotary file to come across here to do it. A little bit difficult to show here because I need to hold this quite tight, so I'll stop filming there and we'll pop back once we've got those two slots done, and you can see what's the end result is. In fact, I brought you back because that was actually going easier than I anticipated. With this rotary file, you can see we can just slowly ease our way. And what we're doing is we're cutting through both sides, both tracks on both sides of the board. Just take some of those edges away, just for neatness. Okay, and if we brush that away, you can now see that where we've gone through with that, I'll use this as a pointer. So they are our two relay contacts which do the switching. So now we've completely disconnected it from the main side, which was this portion, and also on the other side remember that there was a track on the top as well. So what we can now look at doing is sort of clearing that away. I need just to clean this lid a little bit more, and then I shall remove this track here. There's no point for it to be there, so I'll just move it. So basically all I'm going to do is, using the rotary file, in fact actually I'll change the bit on the Dremel, and we'll do that slightly different. But we shall remove this track here, and then our fuse will now solder between these 2 points, and we'll reconnect our cable to here. So back in a moment. Okay, so we've just changed to a rotary burr at the end, which just helps to remove the track a bit easier. And all I'm going to do is I'm just going to clean this bit of track away. And also while I'm here, I'm just going to take away some of the track on the top of that bit. Just clean that up a little bit there, a little bit of brushing. So now we have completely separated this relay now from anywhere near the mains, and we've also put a slot through, so it gives us just that little bit more insulation. The board, on the PCB board, it's quite capable of taking that voltage. The problem is if for some reason this got a little bit damp, or a little bit damp and dusty, and then what you could find is you could actually get mains voltage tracking across the board just through the dampness on the board and any dust, and you'd get voltage leaking from 240 volts across into your low voltage circuit. not really what you want. So by putting these slots in, it gives you an air insulation gap, because you need many thousands of volts to actually jump that gap. But if the board for any reason got slightly damp, or say a bit of condensation and any dust on the board, the only way the mains voltage could get round into this low voltage side of the circuit would be to come all the way around here, down here, and you can see that's a much further track for it to have to go, because it won't jump across that gap. So that's basically what we're trying to do, and we're trying to make these as safe as possible. A simple mod. So our next task now will be to replace this fuse back in, and then put this cable back in and resolder that. So I shall get that prepared and we'll be back in a moment. Okay, having put the fuse back in, at the moment it's not soldered, so we're just going to hold the fuse in place, and then on this side we will be bending this lead over, and also this lead, we'll put that across. And then now what we'll look at doing is to actually solder that lead back in. See if we can give you so you can see it, and me so I can also work on it. This fuse is taking milliamps. It's very low current at this voltage just to run this circuit. But you can now see that we've now fused, put the fuse back in. Just make sure we have got a good clearance on that inductor, so we've got a nice good air gap there. So our next task now will be to put this cable into place. Okay, we return. I've now rerouted this line. Remember, before it was in here, we've now taken it back, rerouted it around the inside of the relay. And as you can see, if we've dropped through to the bottom, and let me find a pointer, and we're now soldered this wire through the hole that was here, and we've soldered this point. You can see it is actually quite tight, but we still have our air gap through all the way around that point. And I'll if I can get this up a little bit closer, you can actually see the base of the fuse. Remembering that's at 240 volts, so it's important that we keep this all well clear. So we've got a nice big air gap there. We've taken this hole as tight as we can over there, so we can get the cable right next to the relay. And I think if we can you can see down from above there, that's a good shot for you. You can see that we have got a good separation between the cable and the mains volt relay. If you're a little bit concerned on that, you could possibly put some heat sleeving over the top of the fuse, but I prefer to actually have the air gap, so there's no way it could touch, and then if it gets damp at all, you can't have it bridged with anything that's touching, which could be dampened and become conductive. I quite like, as long as we've got the good air gap between, you know, we're pretty good. And that's just given us our isolation from our mains from this low voltage part of the circuit now, because as you can see, we will come in on this point for our low voltage, and the one connection will be coming to one side of the relay, and the other connection will be coming from the other side of the relay back to here. So basically these two wires just go to these 2 points, and the rest of the circuit now we've got rid of the mains feed into the relay, so that's all gone. So it's now volt free, and we can now switch anything we want on it. And that basically is the end of the story for this. It's a relatively simple mod, I say, with some basic tools, a fine Dremel and a nice small drill. You do need, as I say, a nice small drill to be able to do this. I say this is the drill I use, which is a small carbide drill for doing printed circuit board work. I appreciate not everybody will probably have that equipment around. It's not the sort of things you want to do with big garden soldering irons and that type of thing, so you do need to be able to get quite close without damaging the other components. But anyway, that is the mod that I do on my boards, so I can use these on many things, you know what I'm doing. So the only other thing really to do now is you'll see that when this board goes in, that this actually states a live and neutral output. And what I've basically found is you can probably make a lie of me now, but with just a sharp blade you can actually just take that off. So I tend to just take those bits off and take the neutral off on there, and I tend to use that to remind me that this no longer has a live and neutral output. That is now volt free. I mean, at the end of the day, if you were to connect it to something, it wouldn't cause a problem, it just wouldn't work because you won't get 240 volts coming through it. So you'll soon realise why, but I just tend to do that on the board. So if I pick one up in a mad rush, as you tend to do, and I say that will now pop back together. That all pops back, and that has now become a volt-free Wi-Fi relay. So that's now suitable for putting onto your charger. I mean, if that's the application you're going to use this for, and you can put your pilot wire. Your pilot wire will just come through into there from the main board, pilot wire into here, from here to the cable going to the car, and that will do all your time charge controlling. Quite simple. Anyway, hope you find that interesting and I haven't bored you too much, and take care.